So welcome to module 3A, where we talk about architectural principles, installation, and configuration. Let's get started. So here we talk about the principles to master at the team level and then at the organization level. And it all starts with enterprise alignment. It is aligning the software delivery lifecycle to what the enterprise is seeking to do for its end customers and users. And it's very important to do this alignment right up front and then periodically along your transformation journey, because the entire software development lifecycle, the DevOps movement, all of this is to serve the end customer and the journey of the enterprise towards that end customer, right? So we are not here to just do things for the fun of them. We are here to make our users' life better and more richer and to serve the goals of this enterprise. And the way that starts happening is at the bottom-up level, where you start giving autonomy to the team to operate at scale. And how do you do that? You put in the frameworks, you put in the principles, you put in the automation so that the team has enough freedom and autonomy to be able to align itself to the enterprise. How does business get involved in this team autonomy? By driving something we call hypothesis-driven development. What is that? That's the new approach to software design and software delivery. It's an approach which is conducive to this new world where moods are changing, the dynamics are changing, the user behavior is changing, and the user has a very flaky state of mind. It's an approach where the product team, the product owner cannot go with one set of solutions to a customer. He or she has to create a couple of different hypotheses, throw them out there, and then see which ones the users are liking. These hypotheses can be in terms of functionality, in terms of user experience, in terms of user design, in terms of product choices, multiple levels. But the idea is you create a bunch of hypotheses, throw them out there in the world and see how your users are reacting. And for the ones that picking up traction, you take that and then you run with it. That's basically the whole mode of hypothesis-driven development. All of this for the reason of giving continuous value to customer. Why would you worry about that? Because that is exactly the goal of what we are trying to do, to give value to the customers. How do you do that? Another way of doing that is by obsessive measurement. Obsessive measurement across all levels of the enterprise. Obsessive measurement on value to customer, on customer engagement, on customer response. Obsessive measurement on the old dynamics of time, cost, and quality. That's a given. Obsessive measurement on things like how is my application behaving, how stable is my application, on the entire observability piece, and then different dimensions to that. How is that achieved? By putting in a service reliability culture. What do I mean by that? Traditionally, a developer's mindset is, hey, I've coded this piece of application, I'll throw it over the wall, not my problem anywhere. You guys go figure. The service reliability culture that we're trying to bring in force is to say, I code it, I build it, I maintain it. So there's no more throwing stuff off the wall. If what you write is crappy, if the service reliability decreases, it is your problem, because you will get that call at 2 a.m. in the morning where there is an issue with the reliability. So you are responsible for the performance of what you created, for the reliability of what you created. That's the mind shift that we're trying to do. across the entire software development lifecycle, right from the developer to the product guys, to the test automation QA guys, to the operations people, everybody. And how do you achieve that? Through obsessive prioritization. What does that mean? Every single day, I ask myself the tasks that I'm about to do today in this sprint, in this quarter, in this OKR, objective key results, or KRAs, whatever you call it in your organization, how are they aligned to the enterprise strategy, to providing value to the customer? It's a consistent, obsessive ask to make sure you pick up the right things that you worked on. So these are some of the principles to master. Now let's look at the practices to master at team and at organization level, which will help you deliver all of this. So we've spoken about continuous integration, the tooling part where the moment code is checked in by the developer, right up to the point where it gets ready to be deployed onto various environments, leading up to continuous deployment across all your environments, and then up to production even. The third one, test automation. It's an obvious one, different shapes and sizes and forms of testing across the software development lifecycle, going from your unit test to your system integration test to your performance test, of course, the regression test, mobile test, all different shapes and sizes of things. Configuration as code. This is again on the reliability front where we are not dependent on a couple of people to run the entire system. The entire configuration of the application, of the infrastructure, of the database, of your systems, everything is codified and put into your GitHub, your Azure repos, whatever source code management system you are creating, you're using. And the idea is when you want to make a code change, treat configuration as code, make the code change in your Azure DevOps, in your GitHub, and then that change will flow across the environments. Similar concept at number 5 with infrastructure as code, where you start treating your infrastructure as code, codify your virtual VMs, your private clouds, your public clouds, your configuration. Any change to the infrastructure has to come through source control. So give the same treatment to your configuration and to your infrastructure as you do to code. And then moving on to release management, it becomes very, very complicated because today's release management is not about figuring out how will I do my release in the next 3 months, in the next 6 months. Today, you're talking continuous release, ability to ship potentially to production at any given point, at any given change. And at that scale, the release management is a different workhorse, especially if you are in a large enterprise where there is a crisscross dependency of functionality across multiple teams, and then not just your teams, across possibly vendors' teams, across possibly third parties, applications that you use, open source libraries that you use, and it's a complex ecosystem. And then finally, observability at different levels. Observability is the ability to observe your system and catch issues coming out, and if possible, catch the alerts that are coming out so that you can fix an issue even before it is created. So that's on the observability layer. Now, 4 pivots on the way to DevOps. Number 1, very, very important, architecture. So as you start moving into this journey of DevOps and cloud and microservice and all of that, one very important element is to re-look at your application architecture. And when I mean application architecture, it's not just strictly limited to the application. It's obviously the database, the data models, how you serve data, the caching, everything, all shapes and forms around the application architecture. Because there is very little merit of taking a monolith and putting it in a container and then shipping it and calling yourself, container ready. Yeah, in some legacy applications or some applications where you don't have access to source control or stuff like that, it probably makes sense. But those are corner cases. If you're moving into the microservice world, make sure your application over a period of time gets into the microservice architecture, right? So have a relook at that. On the engineering side, we've already briefly touched upon storing everything as code. And why you would do that? Traceability, predictability, and transparency. Because you can go to code and figure out who did what, when, where, why. And that reduces the classic issue of environment drift, which is a cause of concern in a lot of enterprises. Number 3, get into the process of experimentation. Not just, here is my solution, I'm sure the solution will work, and I will chug at it for 1 year, and let's hope it works. From going from that standpoint and having a 6 months analysis phase and then a 4-month implementation phase, going from that to thinking, hey, I think this looks like a good idea. Let me do a proof of concept in the next 3 weeks. Let me prove to myself and to my team and to the organization that it is a good idea. Let me do some stuff, improve, learn, implement, and then go back to my senior management, go back to my product management, and let's keep doing this experimentation. Let's keep evolving. Let's keep figuring out how to do stuff. In the process, continuously delivering value to the customer. And the underpin of all of this innovation is a zero blame culture. It's not a you made a mistake versus I made a mistake. It is the thought process of we are innovating together. Let's learn from each other and let's keep moving forward. Let's not get into the mentality of a rollback. Let's get into the mentality of a roll forward. Keep going, keep going. So those are 4 pivots that I have seen work well as organizations start pivoting themselves to this modern era of DevOps and cloud and all of that. So today's enterprise architectures are extremely complex because you're talking about a ton of legacy, whether it's mainframe, whether it's COBOL, whether it's ZOS, some shape form of legacy systems, then a lot of middleware, bloatware over a couple of years. Maybe you've acquired a bunch of organizations, their stuff has moved in. Maybe you've bought a bunch of products from the market and then customized it so much that it doesn't really assemble the original product that you bought. Whatever is the shape and form, for any large enterprise, architecture systems are complex. This is the famous Death Star microservices architecture at Amazon and Netflix. You can Google these and then you'll find interactive diagrams where you can go much deeper and zoom in into all of this and you'll figure out what it means. But essentially, enterprise architectures are very, very complex today. This is the famous DevSecOps reference architecture created by Sonatype. These are the makers of Maven Nexus repositories. This will give you a high-level overview of the complexity that we are talking about across the software development lifecycle. Now, you can pick up any channel, any color stream, and you can figure out the diversity of tools and technologies that are used in any enterprise of a large scale. Okay, let's talk about one more DevOps reference architecture. This is primarily AWS driven, cloud native on AWS using EKS. So it's kind of split into 2 parts. One is the client part or the application part, and the second one is the underlying DevOps part of it. So let's go one by one. So in the client part, you have multiple AWS accounts. Let's say one for dev, one for QA, one for production. Within each account, you would have a separate VPC. Within the VPC, you would have the application firewall, the WAF, and that leading to the load balancer. Now, within each load balancer, you would direct traffic to the front-facing Nginx. This is coming to the private cloud EKS, where our application is hosted. So the front-facing Nginx, which is routing to different parts of the application, let's say the accounting, the billing, the logistics, so on and so forth. Each one of them interacting with a backend SQL database server, for example. And then to keep a watch over all of this, you have namespace monitoring by, let's say, an Elasticsearch, by Prometheus, by Jagger, for the transaction management, for the transaction control and delivery, for the tracing. All of this is then backed by the AWS repositories. The state is maintained through Terraform, and then the RBAC and the validations being done by the AWS on Active Directory. So this is on the client side or the application side. Now, if you move towards the DevOps side, you have EKS cluster, where you have logging, monitoring, tracing using Kibana, Grafana, and Jagger. Then you have the container registry, ECR, Elastic Container Registry. Now, this is where your Docker images are stored. Think of it as a replacement for Nexus in the olden days. Then you have the AWS deployment operator, in this case, the cloud native code pipeline, which is then triggering Terraform and Helm for the configurations. Then you have AWS key management, which is maybe the applications of things like a vault, where you store your key secrets. And then obviously the AWS repository and the code commit, which is where your code is located. And along all of this, you have the SaaS tools, the static code analysis tools with, let's say, a SonarQube, and then you have a Rancher, which is managing management on the, which gives a UI layer to all of this. So this is an idea, a quick walkthrough of how a modern architecture on AWS over EKS can potentially look like. Now, this is obviously a very, very simple application. In terms of the application, it's fairly simple because we've not gone into multiple layers of the application itself and how's that served. On the DevOps side also, it's fairly simple. There are a bunch of other things that we can go into, but this kind of gives you an overview of what we're talking about. Here is another reference architecture, much more simplistic view. For example, if you're, let's say, the code side, your code is probably in Git, your Jira is running your sprint planning, your documents are in Confluence. If you come to the test side, let's say you have JUnit doing your unit testing, Selenium doing your functionality testing, right? Let's say if you go to the monitoring side, you have Nagios for monitoring, Splunk and Datadog, right? If you go to the operate side, maybe your Kubernetes is running your clusters, your configuration management is done by Ansible. Probably you have a bunch of Chef thrown in there as well. So this is another simplistic view of how a DevOps reference architecture could look like. Now let's come to the reference architecture that we will set up in our lab. So you have a developer here at number one. The developer commits code to the source control system. This could be for a new feature. This could be for fixing a defect. And then the code reviews happen, right? Again, within GitHub itself. The moment that happens and the code is merged into the right branch, the continuous integration server is listening onto them, and that triggers a bunch of things. That triggers static code analysis using SonarQube. That triggers unit testing using JUnit. And then it uses the build tool. So it uses the build tool, let's say Maven, to start building the binary, the artifact, the jar war in Maven case, a very simple example, right? And then at step 8, you are ready to do the continuous deployment. You deploy onto one environment, maybe onto a higher environment. And this is a very simplistic CI/CD pipeline with all the toolset listed. We will also set up all of these tools and the pipeline for a simple open source Java application. And then we will demonstrate all of this as well. And as you can imagine, this first part is continuous integration, and then the delivery of this code onto subsequent environments is obviously continuous delivery. So we will look at the practical aspects of this in the lab. So DevOps maturity is a continuous journey, in terms of the tooling, but it's not just the tooling, it's not just the technology, it's a continuous journey in a lot of other facets as well. And let's talk about those now. So doing DevOps is much more than just tools. Doing DevOps is talking about agile, is enabling the agile teams with the capability to be able to deliver stuff faster, better, cheaper. It's also related to the branching strategy, because the way you deliver is determined by the way you branch out your code. It is also setting up the pipelines and going from one pipeline to a pipeline of pipeline. It is also about automated testing across all phases of the development lifecycle. It is also about monitoring. It's about frequent releases. It's about cloud usage. It's about a lot of other things. It's also about team topologies. For example, you might have stream-aligned teams, which means one team doing UI, UX, the other one separately for mobile, and so on and so forth. You might have a centralized enabling team, which means maybe a central DevOps team, which is responsible for ensuring the pipeline and implementation across teams. You might have a complicated subsystem team example, or you might be moving towards the area of platform team, wherein a smaller platform team will establish the DevOps pipelines and the templates for the pipelines and the standards for that pipeline. And then individual DevOps engineers probably embedded within the squads or your team for a specific period of time to make sure that the team ups their level of maturity, is able to operate on their own, and is enabled in terms of technology, in terms of documentation, in terms of skill sets, also in terms of the mental state of I build it, I code it, I build it, I run it, I maintain it. Establishing all of this, and once that is done in a team, pull out from there, let the team be self-sustaining, let the team be autonomous, and expand this principle and way of thinking and technology across multiple teams. Various interaction mode across the teams. You might start with collaboration. You might go to everything as a service, DevOps as a service, environment as a service, and so on and so forth. And ultimately come to the maturity of being a facilitating team, where you facilitate as a team to create standards, to create platforms, to create services in service of the the squads, the team, which are in service to the enterprise, which is in service to its end users. So that's a little bit about team topologies. Now, important also to measure on how you're doing all of this. And the DORA, the DevOps Research Institute, has defined some standard metrics which they consult on. Things like for the software delivery side of it, lead time to change, time to restore service, change failure rate, deployment frequency. These are some of the very standard metrics. And then on the operation side, it's about reliability. What is DORA? DevOps Research and Assessment Research. They come out with a catalog. They've been in business for about 7-8 years. They collect data from thousands of professionals worldwide. It's a very reputed institute. I would highly recommend you to do some research on what DORA is. They publish a state of DevOps report every year. I think they've published about 6 or 7 of these so far. And it's a great piece of research to spend some time on to actually understand the direction in which DORA is going and the direction in which the industry is going. Especially pick up the report for the last 2-3 years, and then you will start to make sense of what's happening out there. Agile is our mindset. Agile is what we want to do. And DevOps is our culture. DevOps is how we want to do it. That is the underlying thing that we are talking about here. And then this is the final slide of this module, where you can look at one part of the elephant, and that's the entire elephant to you. Or you can take 10 steps back and you will have a full view of the elephant in its full glory. For example, DevOps for somebody could be collaboration, integration of the development and the operations team of people moving across from developers to operations for a period of time. It could be about automation for somebody. It is about small incremental deployments for somebody. It's about feature flags. It's about A/B testing for somebody. It's about treating your infrastructure as code, treating your config as code, treating your database as code. It's about feature switches that I just spoke about. It could be Kanban for ops. So DevOps is all of this and more, depending on how you're looking at it. And that's the end of the module, where we've spoken about a lot of things. Thank you.